by decimals. Now, just like we did dividing fractions by fractions, there's a lot of it that just doesn't make sense. So we're actually going to kind of slow walk you through this to help it make sense before we actually show you how to do what we're going to do, okay? We're going to start by talking about our powers of 10, because it's actually a really important concept. So we're going to start in the middle of our table where it says 2 5/10 times 1. So in that line, 2 5/10 times 1, what's 2 5/10 times 1? 2 5/10. Because anytime I multiply a number by 1, it is that number. That's the multiplicative identity of 1. Which basically says if I multiply 1 by any number, I get that number. We're going to work up first, and then we'll come back down. So going to the next line up, if I take 2 1/2, I multiply it by 10, what do I get?
2.50.
No. No. 2 5/10 times 10. 25. I heard just about everything but 25. Okay, guys? Jessica? Now we go to our next line. 2 5/10 times 100. What's that going to be? 250. I go to the next line. 2 5/10 times 1,000. 2,500. Then 2 5/10 times 10,000. Okay. So we've gone all the way to the top of our chart. Do you guys see a pattern? What happened as we went up? Emma? Added an extra 0. Or another way to think of it is what happened to my decimal place? I moved it to the right every time I went up by a power of 10, right? So when I multiply by 10, I move the decimal. Which direction was the decimal going in this case? Right. One time for every 0. So what that means is in 1,000, there's 3 zeros, so I move my decimal 3 places to the right. In 100, there's 2 zeros, so I moved it 2 times to the right. Make sense? Okay, now let's look at what happens when I start going into multiplying by decimals. So if I take my 2 5/10, I multiply by 1/10. Now what do you think my answer is going to be? 25 hundredths. Be careful in how you say that, because when you said 0.25 hundredths, that's actually a different number. Okay? So 2 5/10 times 100th would be? We're already at hundredths. 25 thousandths. So now I need to add a 0 in front of my 2. 2 5/10 times 100th would be? 25 10,000ths. So now I have 2 zeros before the 25. And 2 5/10 times 1 10,000th would be, or no, 100,000th. No, 1 10,000th would be 25 hundred-thousandths. So now I'm up to 3 zeros before the 25. Now what do you notice when I multiply by decimals? The decimal moves 1 left for every decimal place, right? And the key is it's powers of 10. So multiplying by decimals of power of 10 moves left terrible F. Left by 1 place for every decimal place. So I apologize, we just got new smart boards. You can't necessarily see this at home because you're seeing our main board, but our side boards, the picture's not coming through quite as clearly. So I'm going to say it again. Multiplying by decimals of a power of 10, I now move left by 1 place for every decimal place in that power of 10. Meaning, when I multiplied, for example, by 100th or 1,000th, I moved 3 times to the left because there's 3 decimal places. Yeah. This makes sense. Yes, sir. Is there anybody not comfortable with this exercise that we just did? Because we're going to be coming back to this throughout the lesson. Okay? Okay, so it looks like everybody's good. Let's keep moving on. Suppose you're planning to purchase 10 items that each cost $5.35. How can we use mental math to find the cost of the 10 items? In other words, I'm multiplying 535 by 10. So what am I actually going to be doing? I'm multiplying by 10. Wesley? Why once? Good, because there's 1 0 and 10. All I'm going to do is move that decimal place once to the right. So move the decimal 1 space right, because there's 1 0 in 10. So the answer is $53.50. Now, because we use American money, we always have 2 decimal places. So now that the 5 is right next to the decimal, we add a 0 after it. But that's, again, only because we're dealing with American money. 0, yes. There is. That way, that differentiates my 2's from my z's. Because my 2's look a lot like z's otherwise. The way I write my 2's, it looks very similar to z's. So I put a line on the z's to make sure I know what I've written. Okay, our next one, we have the product. In other words, I'm multiplying 12 and 4/10 and some power of 10. And my answer is 12,400. What is the power of 10 that I used? How much did I multiply by to go from 12 and 4/10 to 12,400? Why do you say 3? So what number is that? What power of 10? Huh? 1,000, because 1,000's got 3 zeros. So what is the power of 10? I used 1,000 because the decimal moved 3 places. So far, everything we're doing, does this make sense? Okay, so let's make these into a couple of rules that you guys can write down. So what rule did we just kind of come up with? If I multiply by power of 10, what do I get? What happens? Okay, multiplying by power of 10. I move the decimal. Yes. Oh, sweet. Right. 1 space for every 0. or left 1 space for every decimal. So it goes both ways, guys. Powers of 10, positive ones, I'm going right. Decimals, I'm going left. 1 space for every one that's included. Everybody good on this so far? Okay. Okay, our next page. Go ahead and turn the page. Now, we're going to go through this piece. I'm not going to expect you to model stuff, but just like we kind of did when we were dividing fractions by fractions, I want you to be able to visualize what's happening to help you understand what it is that you're looking at when we do this. Okay? Our first problem, we're going to take 9/10 and divide it by 3/10. So in words, what is it that I'm actually asking you? I'm asking 9/10 divided into groups of 3/10, or how many groups of 3/10 are there in 9/10? Okay, so we've given you these number models to help you see this. So our first line, we're going to call this a 1. So I'm going to color in 9 of the 10, but don't do it too darkly because you need to be able to see the lines. So if I color in 9 of those and I divide it into groups of 3/10, I get 1, 2, 3. So there are 3 groups of 9/10 in there, correct? Aren't there? That's why we're doing this, to show you it's really not Albert Einstein stuff, that this actually makes sense when you think about what it's actually asking you. Now, here's kind of one of the key questions on this, guys, and this is why dividing by decimals doesn't kind of make sense. Is our answer bigger or smaller than our starting value? Bigger. It's actually bigger than either of the values, isn't it? So that's why this becomes difficult. Normally, I try to stress to you guys the importance of making sure your answer makes sense, right? Problem with dividing by decimals is our answers don't necessarily make sense because the way the numbers look. So to say 9/10 divided by 3/10 and get a number like 3 that's so much bigger than either of them, it's kind of mind-blowing. Don't worry about it. Just get confident that what we're teaching you is mathematically accurate, and we'll show you how we're going to get these answers. Okay, our second one, we're going to take 75/100ths divided by 5/100ths. So what do you guys think in words? What does this mean? What are we doing?
How many
75/100ths
7,500 can go into a group of 5.
divided into groups of 5 what? 500ths. So in other words, how many groups of 500ths are there in 75/100ths? So again, on my model, what we're going to do, now I've got 100 of these blocks. We're going to color in 75. So again, we don't have to, this is why we didn't get you the pencils and stuff. We're just doing it quick so we can see how much we're using. So there's 4, 5, 6, 70 plus 5 in the last one. So that gives me 75. And I'm now going to break this into groups of 500ths. So I'm going to circle every 5. So here's 5. There's 1 group. There's 2 groups. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many groups were there? 15. Madison, from where you're sitting, it's actually easier to see the computer. You can just look around Diana. Does that make sense? Can you see that there are 15 groups of 500ths in 75/100ths? Can't see that, Emily?
6 is not the same.
Do you see that we did 75 hundredths? I did 7 full lines is 70 plus 5. That was 75. Do you see that? Do you see it? Then I said, okay, now I need groups of 500. So now I'm just doing every 5. I'm not circling. So there was one group, 2, 3, 4. See what we did? Till I got to 15. So there were 15 whole groups of 500ths in that 75 hundredths.
Was it bigger? Wait, or smaller?
That one was bigger again, but we didn't ask you the question this time.
Wait a minute.
Okay, now we're going to do one more. Let's look at this one. So what is that third one asking us? I've got 75 hundredths divided by 5 tenths. So what is our question? What are we asking in words? Nora? Good. Divided into groups of 5 tenths. So this one's going to look a little different. Our initial is going to be the same as what we just did, right? So I need 75 hundredths. So I'm going to color in 75 of the blocks. There's 10, 20, 30, 40, 50, 60, 75. But now what I'm dividing it into is different, isn't it? Okay? Because this is 100 blocks, and I've got 10 rows of them, each row is 1/10, correct? So for 5 tenths, how many of those rows do I need? 5 of them. So 5 of these makes one of those groups of 5 tenths that it's been divided into. Does that make sense? How much do we have left?
3 tenths. No, 2.
25 out of how many more blocks were there?
75.
100. So 25 over the 50 that are left is the same as a half, or 0.5. So we had one whole and then 0.5 of the next one. So 75 hundredths is 1 5/10, or 1 1/2 groups of 5 tenths. So visually, are you guys seeing how these answers came about?
And also,
What do you mean you have 25? Yeah, out of 50, there's 25 filled in, 25 that aren't filled in. So it's 25 out of the 50 for what was left.
1.5 and 0.5 are just for 75 points.
If you multiply them, the inverse of dividing is multiplying. So instead of dividing, if I multiply the other way, I should get that answer. Yes, Emma. Guys, please quiet down. Because I just did the first one as a whole one. If I looked at the whole thing as one, I would have colored it in 9 of the blocks and then divided them into 3 blocks. You could have done it either way. Okay, turn the page. Let's do a couple of these together. So now, mathematically, let's look at what we just did. Now, I'm going to give you guys a little Mr. Moore hint to try to help you, because I'll be honest, a lot of times when I look at numbers written in this format, I have trouble remembering which one goes in the house, which one doesn't. So for me, it's actually easier to take an initial step and write this as a fraction first. So I rewrite that as 9/10 and 3/10, because now I know who the winner is, right? Now I know who goes in the house. Normally, if I didn't have this extra crutch, I would know based on my answer if it was correct, because I'd know, am I expecting a decimal or a big number? The problem is when I'm dividing by decimals, that natural number sense kind of goes out the window, because as you just saw, we don't really kind of know where the answer is going to end up. It could be a decimal. It could be a bigger number than anything we're working with. So this is an additional step to help you understand what's happening. Now, another thing that helps on this, because this is now in a fraction, can I have a decimal in my denominator, what I'm dividing by? No. Yes, ma'am. We're about to get there. Madison?
Could you just turn them both into the decimal and then just do the change?
No, because I can't do that with fractions. I can't have decimals in fractions. So we're about to do something. Hold on. Oh, I see what you're saying. Had I turned the decimals initially? Yeah, you could. Okay? Because I can't divide by decimals, I'm going to get rid of the decimals. How do we do that? Multiplying by 10. That's why we went through that whole exercise initially, right? So if I have one decimal place, what do I need to multiply by to get rid of it? Jonah, please stop. 10. But if I do something to the bottom, what else do I need to do? Do it to the top to keep my fraction equivalent. So now it becomes 9 divided by 3. 9 goes in the house, 3 is on the outside. What does it equal? 3. Now, had I set this up initially, straight off of this, I could have done that. I could have done 9/10 divided by 3/10. But again, I have the problem of I cannot divide by a decimal. Doesn't make sense. So in order to get rid of it, what would I do? Move it to the right. But if I move this one to the right, what else do I need to do? Move this one to the right. Now I just have 9 divided by 3, so it's going to go 3 times, and I can see the answer either way. So whichever way you want to do it is fine. I'm just giving you a couple of options. Just make sure you understand why you're doing what you're doing and that you can do it successfully. Okay, let's take a look at our second one. I'm again going to turn this into a fraction. So 75 hundredths over 5 hundredths. So 5 hundredths, what would I need to multiply by to get rid of the decimal places? 100. But anything I do to the denominator, I have to do to the numerator, which gives me 75 over 5. So now I'm just dividing 75 by 5. That's going to go once. Bring down the 5. It's going to go 5 times. And I get to 0, so I see that it equals 15, which is what my model showed me and I should have expected. Does it make more sense having seen the models as to why we're getting these answers? Kaylee, are you actually writing all of this down? You are? So I'll be checking. Okay. Number 3. Again, 75 hundredths, but now it's only 5/10. Again, I'm only going to focus on my denominator. The numerator, I don't mind if it has a decimal in it when we're doing this division piece. It's just that divisor because I can't have the divisor by decimal. So what do I need to multiply by to get the 5/10 into a whole number? Times 10. But you may have noticed every time I say it mathematically, when I say the decimal place, it's telling me what I'm multiplying by. 5/10 I multiply by 10. 5 hundredths I multiply by 100. So this now gives me 7 5/10 divided by 5. The winner goes in the house. He's my top guy. 5 goes into 7 once. The decimal comes straight up into my answer. 25 is going to go 5 times, and I end up with 0. So this one equaled 1 5/10. Boys, please stop all the humming. You guys are literally right here by the mic. I didn't say it was you this time. I said you boys, because you guys have both done it, Jonah. Okay? Questions on any of those? Okay, let's do 2 more together. Our next one, we have 52 divided by 4/10. So I have a decimal in my denominator. What do I need to multiply to get rid of it? Times 10. Good job. And anytime I do that to the denominator, I also do it to my numerator, which gives me 520 divided by 4. So I take 520, divide by 4. It's going to go 1. Bring down the 2 is going to go 3 times. Minus 12. Now, here's a really important one, guys. Do I still have another number there? Yes, so I have to put a 0 above that to show that it didn't go in there at all, right? I can't just leave it blank. So what does this equal? 130. 130. And that's another one of those. It's way bigger than any of the numbers I started with, isn't it? Bigger than 52, bigger than 4/10, and I end up with 130. So make sure you understand that it may not always make sense to you, but it is actually correct. Nora? I couldn't hear you. Sean, please be quiet. What? 130. Yeah, there's no decimal in there. Yes, Sean? Don't. As long as you set them up properly, you're going to get the right answer. Okay? Okay, our last one here. Let's do 6 and 24 hundredths and divide it by 20. Do I have any decimals in my denominator? No. So do I need to move anything? No, I don't. I can just set this up. The top guy, he's my winner. He goes in the house. 6 and 24 hundredths divided by 20. Will 20 go into 6? No. So I can put a 0 above that. Remember to bring your decimal straight up into your answer. 20 goes into 62 3 times. Subtract 60. Gets me a 2. Then I bring down the 4. 20 goes into 24. 1 time. Subtract 20. I have a 4. Am I to 0 yet? No. So I need to add a 0, bring it down. And make sure you add the 0 to the 624, not to the 31 hundredths. I had some actually really good math students last class that put that 0 in the wrong spot and messed them up. 20 goes into 40 twice. Subtract 40, and now I'm done. So what did that equal? 0 and 312 thousandths. Any questions on anything we've done so far? Okay, here's your chance to show that you're understanding it. We've got 3 problems here for you. I will give you a hint. This one and this one may be helpful to build yourself a table of values. You guys remember how we did the division algorithm? Okay. So, okay, you guys should, how many of you were able to finish all 3 of them? Ooh, not that many. So watch this. Please watch. Stop talking. Watch. We'll see how many of you guys did what I'm about to do. So we have 3 and 69 hundredths dividing by 3/10. So I'm multiplying these by 10. Gives me 36 and 9/10 divided by 3. 36 and 9/10 divided by 3 is going to go 1, 2. My decimal comes straight up. 9 is going 3 times. So this one equaled 12 and 3/10. Okay? Our next one, we have 338 10,000ths divided by 1 and 3/10. I'm only multiplying by 10 because I only worry about the denominator, not the numerator. Gives me 338 divided by 13. So 338 divided by 13. So because I'm doing multi-digit, we can put together our cheat sheet real quick. So 13. Do what? Actually, if you're not using this, that's not very smart. Hopefully. Okay, once I have the cheat sheet, this should be very easy for us, right? Guys, please stop the chatter. So 2 gives me 26. 78 is going to go 6 times. So my answer was 26. Now, really quickly, did any of you build the cheat sheet? You can get the right answer. Here's my question to you. You guys just watched me do this, right? How long did it take to make the cheat sheet? It takes you an hour to add 13 9 times. Mateo, hold on, guys. Hold on. I'll just let you know straight up. This is where I got really upset with first period, because they were kind of having the same attitude towards building these tables. Does it literally, Mateo, take you an hour to add 13 9 times? Guys, if it does, if it takes you an hour to add 13 9 times, you need to be doing a lot of extra work on math. Okay? Now, you all just watch me. I can probably go back and time this now that it's on video. I'm betting that entire chart probably took me about 50 seconds maximum. Definitely less than a minute. So even if you double that, that's 2 minutes for you guys. In a smaller problem like this, it may not make as big of a difference, but watch this one. So now we're going to 2.943 divided by 2 7/10. We're going to multiply these ones by 10. Gives us 29 43/100 divided by 27. So now I'm looking at a lot bigger numbers here. So this one, my cheat sheet, can actually really help me out a lot. So again, let's take a look. How long does it take to make this? It takes more than 5 seconds. Oops. Okay, we'll finish after lunch. Okay, right before lunch, we had finished up problem 2. I got so focused in on making sure you guys were doing the chart, I forgot to actually be correct in my math and put the decimal in. So your answer was actually 26 thousandths, not 26, which is what I had on the screen before you guys left. So please make that correction if you didn't do that one right. Now, I did wait until you guys came back to build the chart, because I do want to talk about this, guys. This is not just some gimmick, some tool, something that we did once and forget about. This is something that can be extremely helpful for you. So I want to make sure you understand the importance of using these charts, because, again, they're not hard to make. Literally, all you're doing is you're writing 1 through 9 in the first column. And then whatever my divisor is what I'm adding every time. In this case, it's 27. Is it difficult to add 27? It shouldn't be. If it is, you need to practice this to make it so it's not hard. So I add 27 and 27, we get 54. Boys, you two need to stop all the chatter up front. Now I'm just adding. 7 and 4 is 11. 81. 7 and 1 is 8. 8 and 2 is 10. 7 and 8 is 15. So I'm carrying a 1. 7 and 5 is 12. So I'm carrying a 1. 5, 6, 9, 8, 16. So 10, 1. And then 13. Do I expect you to do it as fast as I just did? No, not initially. But literally, guys, all you're doing is adding. How long did it take to do the chart?
21 seconds.
I mean, if you're on the video, you can actually check it, but it doesn't take long. Once I have my chart, this is easy, because now 27 goes into 29 once. Subtract 27. And here's where, and just for the record, Ayana's the one that caught my error. She's like, Mr. Moore, you kept talking about bringing the decimal up, but then you didn't do it. It's because I didn't write the decimal down. But do make sure you bring your decimal straight up. So 24, will it go into 24? No, so that's a 0. Bring down the 3. 243 it goes 9 times. Since I already have all of my numbers written down in the quick reference chart, was that hard to do that math? No. And I knew exactly where every number was. 1 and 900. Any questions on any of those 3? Okay, let's turn the page. Now, turning the page is your homework. So here is your homework. Now you'll see, overall, we were pretty nice. Most of them are going to be single digit, so doing the division shouldn't be hard. We have a few multi-digit ones that building that chart can be helpful for you. The 12 you might not need to. 12's not that hard. But I would definitely build the chart for the 34 and the 95. Okay? And then down here, these shouldn't be too bad, just a couple word problems. Make sure you're understanding those. As I recall, this one might give you a little bit of trouble. Actually, it's not bad. No? I'll let you do it. We'll give you something to do for homework. Now, I need you guys to go ahead and put the packet away. Pull out your modules and turn to page 62. Alyssa, do you have a question? No? Okay. Will be if you keep talking and don't open up your module like I just asked you to do, Jonah. So we'll see at home. Maybe Jonah will give us some extra homework. Module 2, page 62, Jonah. Guys, make sure it says 6-2 on the top right. 6-2 on the top right, you're turning to page 62. 6-2 on the top right, you're turning to page 62. Page 62. Okay, our first one. This one goes pretty quickly, especially if we write this out. So if I write it out as a fraction, we have 5/10 divided by 1/10. So I'm going to multiply those by 10. So really all I'm saying is 5 over 1. So 5 divided by 1 is just going to go 5 times. It is simple. Okay. Let's come down to our next one. 186 divided by 23. So they did that initial part for you to show you how to set that up. So this one isn't too bad. 186, build a chart for our 23. Well, yeah, there's more room up there. So 23, 46, 69, 12, 8, 92, 5, 11, 8, 13, 11, 5, 6, 4, 8, 1, 7, 10. That's an 8. So again, do I expect you guys to be able to do the chart as fast as I do? No, I do not. But do I expect you to be able to do this relatively quickly? Yeah. I mean, guys, you're just adding 23 each time. So my recommendation is do the chart by yourself, and then you can double check your numbers against what I put up here. But the more you practice doing it, the quicker you'll become at it. Right, Jonah? So you actually have to write it and do it, not be playing with whatever it is you're playing with. 161, yes. 184. And then 207. So now that I've got the quick reference chart, 186 divided by 23, how many is it going to go? It's going to be 8 times. So that's 184. Gives me a 2. Not at 0 yet, so I added decimal. Bring my decimal straight up into my answer. Bring the 0 down. 23 won't go into 20, so I need to put a 0 above that one. Then I add another 0. Now I'm at 200, so that's going to be another 8. So we subtract 184. Gives me 16, still not at 0, so we'll add another 0 and bring it down. 23 is going to go into 16 7 times. And we'll just round to the nearest hundredth, so that gives me enough to do my rounding. So my answer becomes what? If I'm rounding to the nearest hundredth, the 7 means the 8 becomes a, Nora? 9. Excellent. So that's going to be approximately 8 9/100. You good, Sylvia? Which part's the processing part? Do you understand the part about multiplying to get rid of the fraction, the decimals in the denominator? Actually, let's take a step back. Do you understand the part about turning it into a fraction? Okay. Do you understand the part about getting rid of the decimal in the denominator? Okay, that's where that power of tens piece comes. To get rid of the decimal, I just see how many decimal places there are, and that's what power of 10 I'm going to multiply by. But I'm only focused on the denominator. Why? Because that's my divisor. That's what I'm dividing by, and that can't have a decimal. Does that make sense? So I don't care about the numbers in the numerator because I can do the decimals in the numerator. That's not an issue. It's the decimals in the denominator. I can't divide by a decimal, just like I can't divide by a fraction. Okay? Okay, number 2. We're not actually going to do this one because the numbers get too big. I'm not going to punish you guys like that much, but we'll do this one. 1404 over 4 6/800. So what do I need to multiply by to get rid of the decimals? Is 10 going to get rid of the decimal?
No.
Will 100 get rid of the decimal?
Yes. Yes, it will.
1,000?
Yeah.
How many decimal places do I have?
No, it's 100 because
No, just in the denominator. 2. So how many zeros do I need? 2. 100. Don't need 100 zeros, JJ. Okay, so I could do that math, but it's not going to come out even, so I'm not going to make you do that because it would get into decimals again. And we've only got 15 minutes left. I don't want to spend that time doing that. Does everybody have this page written down? Anybody need more time writing down this page? Let me re-ask that. Okay, I'll give you another minute. Quick question. Are you guys seeing the benefit to the multiplication tables? Does anybody not see the benefit to it? Test will be next week. I'll need to talk to Miss McShann. It might be on Monday, or we might do a review Monday and do the test on Thursday. The problem is if we give you guys the test on Thursday, that means B-Day won't be doing it until the next Wednesday because you guys have Friday off next week. That's when we finish up our grades for this semester. Then Monday is a holiday. Tuesday will be a Wolverine Day, meaning they would go almost a week between the review and the test, which may be worse than giving you guys the test Monday, Wednesday. So Ms. McShann's supposed to be back tomorrow. I'll talk to her then, and we'll come up with which way we want to do it. Okay, let's go to the next page.
number 3.
Yep, number 3. So on this one, we've got 162 thousandths divided by 36 thousandths. Have you guys noticed something? If I'm saying the numbers properly, mathematically, it's actually telling me what to multiply by, isn't it? So 36 thousandths, what do I need to multiply by to get rid of the decimals? 1,000. So if you understand your decimal places and how to say it properly, you automatically know what to multiply by. So that's going to give me 162 divided by 36. So we can build our chart for 36. So we're adding 36. Can everybody here add 36 to two numbers? So 6 plus 2 is 8. 3 and 7 is 10. 6 and 8 is 14. Carry the 4, makes that a 1. 10, carrying a 1 makes that an 8. 6 and 0 is 6. 11, 216. 12, so 4, 5, 252. 8, 8, 2. 14, so I'm carrying a 1. 11 becomes a 12. And I have the chart, doing the actual math, becomes relatively easy. Will 36 go into 1? No. Into 16? No. So won't go into either of those. 162, it's going to go 4 times. Subtract the 144. Gives us an 8. Now I'm into my decimal places. So 180. 36 goes into 180. 5 times. That actually turned out pretty easy, right? Can I wait? I can. The question is, am I willing to? Since I don't have Miss McShan here today to slow me down and make me stop for you guys.
Are you kidding me?
No, she's not here. You didn't notice?
Yeah, I know she's not here.
Wow, Sean, she's going to be really upset you didn't even notice she was gone. Micah? Guys, quiet down, please. Guys. Yes, Micah? What, Jessica? Well, I guess I know who my least favorite at your table is now. At least Andrew likes me. What about you? Guys, any questions on that one? Second, let me bring it back. Is it difficult to build the chart? No. Once I have the chart, is it difficult to do the math? No. So if you'll do this, it actually comes out quite nicely. So let's do one more together, just because we're almost out of time. So this one becomes 25 2/10 divided by 72 hundredths. So what am I going to multiply by to get rid of my decimal? 100, because it's hundredths on the bottom. So I multiply them both by 100. Now here's why I want to do this. So if I do that by 100, I end up with this empty bucket, right? What do empty buckets get? Zeros. So any of the B3 students that are listening for Miss McShan, when we're talking about empty buckets, those always get zeros. No, it's funny because yesterday when she was teaching B3, she mentioned the empty buckets, and they didn't know what she was talking about because I guess Miss McShan doesn't normally say that. Okay, so let's do our table. 72. So 72, we're just adding 72, guys. 144 becomes 6, 11, 216, 8, 8, 2, 10, 15, 16, 2, 13, 4, 10, 6, 7, and 8, 14. Realizing it's going to take you guys a minute. Again, Sean, I actually recommend do this on your own and then check your answers against mine. Do what, Jasmine? Yeah. It's not the same graph, but every other number is the same. So you had half of the numbers. Yeah. Because it was 72. So half of these numbers you already had. Yeah. So now let's do the actual math. Why would you do that? It's 72. Guys, please quiet down. One of the big ones I want to make sure everybody did. When you multiplied by 100 here, make sure you got the 2,520 that you're dividing by. So it won't go into 2, won't go into 25. 252, it's going to go 3 times. So let's subtract 216. Gets me 6, 360. It actually worked out evenly. So what did that equal? 35. No, I just showed you. I'm not kidding you. Wow, Sean. Questions on anything that we are doing on these dividing decimals? Okay. Let's turn the page. We got time, it looks like, for one more. Now, guys, I'm going to do something a little different on this one. So for those of you that don't like turning it into a fraction, you don't have to. I can just go like this. I can write the number, 893 and 76 hundredths, dividing it by 21 hundredths. Okay? But in order to solve it, I do have to get rid of this decimal. So I move it twice, meaning on the inside, I also move it twice. Is everybody okay with that? Given the way we've shown you in the fractions, do you understand why we're doing that? Hope so. So now I just build my chart. 21. Should be easy. 21 is really easy to go. 21, 42, 63, 84, 105, 126, 147, 168, 189. So will 21 go into 8? We'll go into 89. 4 times. Subtract 84 gives me a 5. Bring down the 3. 53, it's going to go twice. Subtract 42 gives me 11. Bring it in down to 7. 117 goes 5 times. Subtract 105 gives me 126, which works out nice and even. 126 gives me a 0. So what did that equal? 4,256. Yes, Wesley. I'm sorry? Yep. I just did it on the numbers this time instead of doing the fraction first, so. I was just saying I'm showing you the other way to do this. You don't have to go through that fraction step if you don't want to. If you feel comfortable just writing the numbers down, this is okay. But again, for me personally, I like the fraction way because that helps me feel more comfortable with which number goes in the house. Any questions on anything we have covered? Okay. On your homework, there's 3 of those that you probably should be doing the table on. 3 of them. If it's single digit, guys, you don't have to do the multiplication table. My assumption is you know your multiplication facts up to 1 through 9 at least. Good. So you don't have to do a table for them. Okay?